Welcome to the Deep Dive, where we cut through the noise and deliver the essential insights you need to be truly well-informed. Today we're plunging into a topic that sits right at the heart of our increasingly digital world: artificial intelligence. Specifically, we're talking about large language models, LLMs. The powerhouses like ChatGPT, Bard, Claude. They're absolutely redefining how we access information, how we write, maybe even how we make critical decisions. Their potential to enhance productivity, analyze these huge data sets, and improve efficiency across so many industries, including something as sensitive as healthcare, feels almost limitless. But there's a fascinating and, well, at times pretty unsettling paradox at play here, isn't there? Despite all this incredible sophistication, these models can sometimes generate what we've kind of come to call hallucinations. They produce outputs that sound incredibly convincing, yet are factually incorrect or even entirely fabricated. It's like they're confidently just making things up.
Exactly, and that's precisely our mission for this deep dive. We're going to pull back the curtain on what AI hallucinations truly are. We'll explore the surprising reasons why they occur, and most importantly, unpack their significant implications, especially in fields where accuracy is literally a matter of life and death, like healthcare. And we'll also equip you with actionable strategies to minimize these risks and, crucially, spot them when they do appear. Today, we're drawing from a really robust range of sources, peer-reviewed articles from medical journals like Curious, Annals of Family Medicine, insights from tech leaders like IBM. It gives us a broad view, helps see the complete picture.
Okay, great. So let's start right at the beginning then. What exactly is an AI hallucination? Because when you hear the word hallucination, you probably think of a human experience like, I don't know, seeing shapes in clouds or faces on the moon. How does that map onto something as logical as a computer model?
Well, that's actually a great way to frame it. The analogy is quite fitting in a way. In the AI world, it's when a model essentially perceives patterns or maybe more accurately generates information that is non-existent or completely inaccurate. This leads to outputs that can be nonsensical or just plain wrong. It's not that the AI is seeing things like we do, but it's fabricating information that isn't grounded in its actual training data or, the real world. To get even more precise, one of our sources actually quotes ChatGPT's own definition of an artificial hallucination. It calls it the generation of content that is not based on real or existing data, but is instead produced by a machine learning model's extrapolation or creative interpretation of its training data. And this isn't just about text either. These fabrications can pop up across various forms, images, audio, even video sometimes. Essentially, the model is creating plausible-sounding stuff by creatively blending elements it's learned, but the final result just doesn't hold up to factual scrutiny.
And this is where it gets truly unsettling, right?
Yeah.
Because these errors, they aren't presented with a disclaimer or a sort of digital shrug. I think Google's developers call them errors with confidence. So why? Why do these advanced AIs, these complex mathematical models, sound so utterly convinced when they're basically just making things up? Is it a flaw in how they learn, or...
That confidence is the key, and it really stems from how these models are built. They are fundamentally designed to predict the most probable next word or the most probable pixel based on the massive amounts of data they've consumed during training. They don't possess a concept of truth or factual accuracy in the way humans understand it. So if their internal prediction mechanism leads them down a path of plausible sounding but incorrect information, they deliver it with the same conviction as if it were completely accurate.
Okay, that makes a bit more sense. It's just predicting, not knowing.
Exactly. And digging deeper into why this happens, we can point to several underlying reasons. One big factor is something called overfitting. Imagine a student who just memorizes every single question and answer from one specific textbook for a test. They might ace that test, right?
Absolutely.
But give them a slightly different version or ask them to actually apply that knowledge in a new context, and they'll struggle. The AI can do something similar. It learns patterns too closely from its specific training data. It becomes brilliant at recalling what it's seen, but it struggles with novel inputs, leading it to invent rather than genuinely extrapolate.
Right. Memorization versus understanding.
Precisely. Then there's the critical issue of training data bias or inaccuracy. This is huge. If the vast input data used to train the AI is flawed, incomplete, biased, or just unrepresentative of the real world, well, the AI's outputs will inevitably reflect those flaws. It's the classic garbage in, garbage out principle. Like teaching a child history using only one very biased book, their understanding is going to be distorted.
Makes sense. You can only be as good as your teacher, or your data in this case.
Exactly. We also see issues arising from high model complexity. Modern AI systems are incredibly advanced, often trained on vast, unsupervised datasets with literally billions of parameters. While this gives them amazing capabilities, it also means they can sometimes produce content that's a creative but ultimately distorted blend of things they've learned. Think of it like a mosaic made from perfectly accurate individual tiles, but the overall picture doesn't quite make factual sense, or maybe even seems a bit surreal. They're pattern matching machines, and sometimes they create patterns that aren't really there.
So they get lost in their own complexity sometimes.
Kind of, yeah. And finally, a significant cause is simply a lack of constraints. AI models might hallucinate because they don't always have clearly defined boundaries or probabilistic thresholds that limit their possible outcomes. Without these strong guardrails, they have perhaps too much freedom to invent, exploring pathways that might look statistically plausible within their model but are factually wrong in the real world.
Okay, so it's this mix of maybe memorizing too much, learning from flawed data, being super complex, and not having enough rules. That paints a clearer picture. But what does this all mean when these systems get applied in really critical areas,
Right.
like healthcare? Because that's where the stakes get incredibly urgently high.
Exactly. That's the crucial question. It's one thing for an AI to, invent a fun fact about a celebrity. It's entirely different when it's advising on medical treatment. Let's look at some chilling real-world examples that really drive this home. There was a striking case published in Curious by Alcussi and McFarlane. ChatGPT was asked about a specific condition, homocystinuria-associated osteoporosis. It gave a plausible-sounding but incorrect link to vitamin K. But the truly alarming part came next, when asked for references to back this up.
Oh, I bet I know where this is going.
Yeah. The AI generated 5 completely non-existent paper titles. And PubMed IDs, those unique identifiers for medical papers, the IDs it provided belonged to totally unrelated papers. Let me just repeat that for clarity. None of the paper titles existed, and all the PMIDs were for different unrelated papers.
Wow. So it wasn't just wrong. It actively, inventively fabricated an entire academic trail to support its wrong answer. That's genuinely deceptive.
It really is. And in another instance from the same source, ChatGPT confidently wrote a whole essay about liver involvement in a condition called late-onset Pompe disease, or LOPD. In reality, that link hasn't been reported. It just made up a medical connection that doesn't exist and presented it as fact.
And it's not just medicine, right? You mentioned other fields too.
No, absolutely not. We saw that notorious case involving a New York lawyer. He faced sanctions because he submitted a legal brief containing fabricated case references that were generated by an AI. And these weren't just vague references, they included convincing details like case names, judicial opinions, citations, all completely made up, but plausible enough to initially fool a trained professional.
Which means a human lawyer then has to waste precious time double-checking every single citation, assuming they even catch it. What about examples with a more direct impact on patient care?
That's where it gets even more concerning and potentially dangerous. Perhaps one of the most compelling examples involved GPT 3.5. It recommended the antibiotic tetracycline for a pregnant woman diagnosed with Lyme disease. Now, tetracycline is effective for Lyme disease.
There's a but coming, isn't there?
A huge but. Tetracycline is absolutely contraindicated in pregnancy. It carries severe risks to fetal development, affecting teeth and bones. The correct treatment in that specific scenario is actually amoxicillin. Thankfully, in this reported case, a knowledgeable human physician spotted the error and had to override the AI's dangerous advice.
That is genuinely terrifying because it's not just inventing a paper title there, it's recommending an action that could cause direct, irreversible harm to a patient and her unborn child. Those errors with confidence aren't just misleading in that context, they're actively dangerous.
Precisely. And it gets even more insidious, especially for busy healthcare professionals. The most hidden risk isn't always these blatant fabrications like non-existent papers or clearly dangerous drug recommendations. Often it's more about nuanced distortions. Subtle things like misplacing clinical guidelines slightly, suggesting a dosage that's a little off, or maybe inventing a minor side effect that might not raise immediate red flags for a busy doctor.
Right, something that sounds plausible enough to slip through the cracks.
Exactly. An LLM might claim, say, an imaging test is the gold standard, citing some partial or maybe outdated evidence. And because it sounds so authoritative, it might lower a busy doctor's guard. They simply don't have the bandwidth to rigorously check every single assertion the AI makes.
It's clear these issues are pretty widespread then, stretching beyond just medicine and law. I remember hearing about Google's Bard incorrectly claiming the James Webb Space Telescope took the first pictures of an exoplanet.
Right, that was a big one early on. Or Microsoft's Sydney chatbot claiming it fell in love with users. The range is broad.
The more I hear about these cases, the more I wonder, how on earth do we even begin to spot these subtle, confident errors? And crucially, what do we do when we find them, or even just suspect them?
That's the critical challenge, isn't it? And thankfully, researchers are actively developing methods to both measure and detect these hallucinations. One approach is using metrics like FACT score. Think of it as a precision-based tool. It evaluates factual accuracy by comparing the AI-generated text against verified data sources. So, for drug information, it might check against authoritative medical databases.
Hmm.
A high FACT score means the text aligns closely with known facts. A low score is a big red flag for inaccuracies. It's a step towards quantifying trustworthiness.
Okay, so like a fact-checking score for AI output.
Sort of, yeah. Then we have more specialized tests, like MedHalt. That stands for Medical Domain Hallucination Test. It's like a rigorous stress test specifically designed for AI in medical contexts. It includes various reasoning hallucination tests, or RHTs. For instance, it uses a false confidence test. This directly targets that AI tendency to sound certain even when it's wrong. Can it justify its answers appropriately? It also pushes the AI to see if it can recognize when none of the provided answers are correct, that none of the above test, rather than just guessing, and can it identify and handle nonsensical or fake questions.
So it's testing the AI's self-awareness and honesty, in a way.
In a computational sense, yes, it's about building AI systems that are more reliable, especially when the stakes are this high. These tests are vital tools for development and validation.
Okay, so knowing how to measure and detect these flaws is one part, but the other half is actively working to prevent them in the first place, right? What are the key strategies we can actually implement to keep these hallucinations to a minimum?
Absolutely. Prevention and mitigation are key. The first, and arguably the most crucial strategy, is implementing human-in-the-loop systems, often abbreviated as HITL. This just emphasizes that human oversight is paramount. Domain experts, doctors, lawyers, scientists simply must review and validate AI-generated content before it's finalized. This is especially true in complex fields like medicine or law, which require nuanced understanding, ethical judgment, things AI currently lacks. Plus, continuous human feedback helps refine the models over time. It's a virtuous cycle.
So always keep a human expert involved. Makes sense.
Definitely. Another vital step is focusing on high-quality training data. We touched on this earlier. The AI is only as good as what it learns from, so using diverse, balanced, well-structured, and relevant data sets is crucial. It minimizes output bias and significantly improves accuracy. It means really curating the knowledge the AI learns, ensuring it's not just vast, but also accurate and representative.
Better ingredients, better output.
Pretty much. Related to this is the need for dynamic updating of knowledge bases. AI models, particularly in fast-moving fields like medicine, need regular updates. Ideally, close to real-time updates with the latest information to ensure they stay current and accurate. An AI trained on last year's medical guidelines might be dangerously out of date.
Right, knowledge isn't static. What about how we interact with them? Does that matter?
It does, significantly. Focusing on the specificity of prompts is something users can actively control. Clearly defining the boundaries and expectations in your prompts helps reduce the scope for hallucinations. The more precise you are with your request, the less room the model has to, well, creatively interpret and generate incorrect content.
So better questions lead to better and hopefully more accurate answers.
Generally, yes. For developers, testing and continual refinement are absolutely key. Rigorous testing before deployment and ongoing evaluation are vital to catch issues, improve performance, and allow for adjustments as data and knowledge evolve. And as another layer of defense, implementing automated fact-checking systems can serve as an initial filter. These systems can identify and flag potentially incorrect claims for that crucial human review.
Okay, lots of technical solutions. What about for the end user, say a doctor using an AI assistant?
For you, the listener, and especially for professionals like doctors or lawyers, it's imperative to verify AI-generated responses. Always check against reliable, established sources, peer-reviewed medical literature, official legal databases, etc. And if you do spot errors, report them. This feedback is incredibly valuable for improving the models. Finally, fostering collaboration between clinicians, legal experts, AI scientists, and developers is essential. Working together helps continuously improve the data, refine the models, and advocate for better standards and more diverse data sets.
So it's really a multi-pronged approach. Better data, better testing, smarter prompting, human oversight, and ongoing verification. Beyond these practical steps, though, this raises some really big questions, doesn't it? What are the broader ethical, legal, maybe even philosophical implications here? especially when that line between human responsibility and AI output gets so blurry.
This is truly where the conversation gets complex, and honestly, where we don't have all the answers yet. First, there's even a debate around the term hallucination itself. Some argue that AI misinformation is actually a more accurate and less loaded term.
Why is that?
Well, the argument is that hallucination risks anthropomorphizing the AI, attributing lifelike, perhaps even conscious characteristics to it, which isn't accurate. It also, maybe inadvertently, could stigmatize individuals who experience actual human hallucinations. So some advocate for using misinformation because it's a more neutral description focusing purely on the false output, not some imagined internal state of the machine.
Interesting point about the language we use. What about the responsibility aspect?
That's the million-dollar question, really. The issue of accountability and professional burden. Think about it. If an LLM suggests a flawed diagnosis or a wrong treatment plan, and a physician follows that advice, who is held responsible? The doctor, the AI developer, the hospital system that implemented the AI. This remains largely unresolved legally and ethically. Current professional guidelines are still scrambling to catch up. It's a huge gray area.
And it puts a huge weight on the professional using the tool.
Exactly. And there's a paradox here. While AI promises to lighten the load, the additional vigilance required from professionals to constantly fact-check the AI output can actually increase their workload and cognitive burden. Especially for, say, busy family physicians who need a vast breadth of knowledge. It adds this whole new layer of checking the checker.
So looking ahead, what needs to change from a policy perspective?
Well, there are clear needs. We likely need to modify policies for evaluating things like scientific manuscripts to include AI output detectors and demand clear disclosure if AI tools were used in the research or writing process. There's also a strong call for establishing specific regulatory frameworks and guidelines, particularly for AI in high-stakes areas like healthcare. This would likely involve mandating regular audits for safety, efficacy, and bias.
Regulation seems key.
It does. And alongside that, we desperately need educational initiatives. We need to train AI developers on the ethical implications and potential pitfalls like hallucinations. And we need to train users, doctors, lawyers, everyone on how to use these tools responsibly and critically. Finally, promoting public-private partnerships and increasing funding for dedicated AI safety research is crucial. This will help accelerate the development of more robust detection and mitigation strategies.
It seems like ultimately, as we integrate AI into healthcare and other critical fields, that fundamental principle of primum non nocere first, do no harm, has to be front and center.
Absolutely. That has to be the guiding principle. The goal isn't or shouldn't be to abandon AI entirely. It just offers too many potentially transformative benefits. Instead, it's about advocating for a cautious, stepwise integration of these tools. That means a continuous cycle, constant monitoring, rigorous testing, adaptive enhancements based on feedback and new data, and always accompanied by vigilant oversight from trained, critical thinking professionals. While AI holds substantial promise, actively managing its inherent limitations, especially these hallucinations, is absolutely essential if we want to build genuinely reliable and trustworthy systems we can safely integrate into our lives.
It's a complex balance, definitely. The power is immense, but so is the need for caution and critical thinking. And maybe that leads to a final thought for you, our listener, to consider. As AI becomes more deeply woven into every aspect of our lives, especially in critical decision-making, what new form of vigilance might AI ultimately demand from us? And what does that really mean for how we learn, how we trust, and how we apply knowledge in every field going forward? It's certainly something worth deeply considering as we navigate this new era.